Every single light in that building has been off for months, not because of a power failure, because there is no one inside who needs them. China's dark factories are not a concept paper or a tech conference slide deck. They are running right now, all day, every day, in complete darkness, and the numbers behind them are the kind that make you stop and reread the sentence twice. Xiaomi opened a facility outside Beijing that covers 81,000 square meters, roughly the footprint of 11 football fields placed side by side. The plant cost the equivalent of $330 million. It runs 24 hours a day, 365 days a year, with 0 humans on the production floor. Not a skeleton crew, not a night shift. 0. 11 robotic production lines churn out one finished smartphone every 3 seconds. That is 10 million devices a year, and not a single pair of hands touches any of them. But here's the part almost nobody talks about. Xiaomi is not the story. It is just the example that fits on a headline. The real story is the system behind it. Who built that system? Why they built it, and what it means for every country still running its factories the old way. Stay for that. To understand what is actually happening, you have to go back to 2015, when China launched a program called Made in China 2025. The explicit goal was to stop being the world's low-cost assembly floor and become its technological engine instead. Robotics, artificial intelligence, and smart manufacturing were the 3 pillars. The government did not just announce it and wait. It funded it, subsidized it, and held companies accountable to specific targets. By 2022, Chinese factories were already installing 290,000 industrial robots in a single year, accounting for 52% of the entire world's total in that calendar year alone. Then, in 2024, that number rose again. China installed 295,000 new industrial robots in 12 months. The United States in that same year installed 34,000. That gap, 9-to-1, is not a rounding error. It is a structural shift in who controls the machines that make everything. Think about what that gap translates to in physical terms. Today, China operates more than 2 million factory robots. That is more than every other country on the planet combined. If you stacked that many industrial robot arms end to end, the line would stretch farther than the distance from New York to Beijing and back again twice over. And they are all working, right now, in the dark. But it gets crazier. The number of robots is only half the equation. The other half is what those robots are doing and what is directing them. Inside a dark factory, there is no foreman, no quality inspector walking the line, no maintenance worker checking dials. Instead, the facility runs on a stack of technologies that did not exist at commercial scale even a decade ago. Infrared cameras and LiDAR sensors, the same technology that helps autonomous vehicles navigate city streets, give the machines the ability to perceive their environment without any light at all. Computer vision systems inspect every single product on every single line, checking tolerances that no human eye could catch consistently at that speed. Autonomous guided vehicles move raw materials and finished goods across the factory floor, routing themselves around each other in real time without a dispatcher. And above all of it sits an AI layer, the operational brain, reading data from every sensor, every arm, every conveyor simultaneously, and adjusting the entire system every few seconds to optimize output, predict maintenance needs before something breaks, and reduce energy consumption while doing it. The International Energy Agency estimates that removing human-centric infrastructure from a facility, the lighting, the heating, the break rooms, the ventilation tuned for occupied spaces, can cut industrial energy use by 15 to 20%. Across hundreds of factories, that number becomes a strategic advantage that compounds every quarter. That is the machine. Now, here's the twist. The companies building these facilities are not just using robots. They are building the robots themselves. A decade ago, China imported most of its industrial automation hardware from Japan, Germany, and South Korea. That supply chain dependence was a vulnerability, and Beijing treated it as one. Today, Chinese manufacturers supply 54% of all industrial robots sold domestically, up from under 30% 10 years ago. Companies like S-Tune and Siosun are now producing factory robots at commercial scale for global buyers. And Chinese robot exports grew by 28% year over year in 2025. The country moved from being the world's biggest buyer of automation to being its biggest seller. That transition happened in less than a decade. Here is why that matters more than any single factory opening. When the United States or Germany or Japan needs to automate a factory, they increasingly have to source the robots from somewhere. The most cost-competitive supplier on the planet right now is Chinese. That means even countries trying to compete with China's manufacturing base are in some cases buying the tools to do it from China. None of the top 10 industrial robotics companies in the world are headquartered in the United States. The American industrial robotics market is estimated at a few billion dollars. China's is estimated at $47 billion. That is not a gap you close with a press release. Analysts at Andreessen Horowitz, one of Silicon Valley's most prominent technology investors, have framed this as what they call a potential Toyota moment on steroids. The reference is to the 1980s, when Japan's automakers did not just outcompete American manufacturers, they redefined what a car factory was supposed to look like, and the American industry spent 15 years scrambling to catch up. The argument now is that China's mastery of physical automation could do the same thing to global manufacturing as a whole. China's own projections do not suggest slowing down. In early 2025, the country's National Development and Reform Commission announced a state-backed venture capital fund aimed at robotics, AI, and cutting-edge industrial technology. The fund is designed to pull in nearly 1 trillion yuan over 20 years, which translates to roughly $138 billion. That is not research money. That is deployment capital, meant to industrialize the next generation of systems before competitors have finished debating whether to fund the previous one. And the next generation includes something that makes the dark factory look like a warm-up act. Humanoid robots, not the clunky, slow-moving prototypes that circulated on social media a few years ago. Companies like Unitree Robotics in Hangzhou are producing bipedal machines capable of navigating real factory environments, picking up irregular objects, adapting to new tasks, at a price point a fraction of what comparable American firms charge. The Chinese government has formally designated humanoid robots a frontier technology and is backing domestic production with the same combination of subsidies and scale that it used to dominate solar panels, electric vehicles, and now conventional industrial robots. If that strategy plays out the same way it has before, the endgame is a factory floor that does not just run without humans. It runs without the fixed infrastructure of a traditional factory. Robots that walk, adapt, and retool themselves rather than fixed arms bolted to a specific station mean that the same machine can build a battery in the morning and a circuit board in the afternoon. The factory becomes software. The hardware reconfigures itself. Here is what the scorecard looks like right now for the countries watching this from the outside. Germany sits at 415 industrial robots per 10,000 manufacturing workers. The United States sits at 295. China is at 470 and climbing, with robot output growing at 28% per year. Meanwhile, China's manufacturing workforce has contracted from 115 million workers in 2013 to below 85 million in 2025, a drop of over 30 million people, even as Chinese exports hit record highs in early 2026. That combination, fewer workers, more output, lower unit cost, is not a productivity improvement. It is a structural reordering of what it costs to make anything. Oxford Economics projected that 12 million Chinese manufacturing jobs could be displaced by robots by 2030. That number may turn out to be conservative. And it carries its own internal tension, because a country does not automate 30 million jobs out of its industrial workforce without significant social pressure building somewhere. Worker protests in Guangdong in 2023 over automation fears were a signal of that pressure. The government's response has been to invest heavily in retraining programs, directing workers toward roles in AI oversight, robotics maintenance, and data management. Whether those programs move fast enough is one of the open questions that no one in Beijing has fully answered yet. But none of that friction slows the machines. The lines keep running, the arms keep moving, the floor stays dark. And this is just the beginning. The question that the dark factory era actually forces onto the table is not whether this technology works. It demonstrably does. It is not even whether China is ahead. The numbers are what they are. The real question is, what happens in the countries that are still deciding whether to treat this as a headline or a strategy problem? The United States added 34,000 industrial robots in 2024. China added 295,000. Every year that gap holds, the distance between the two manufacturing ecosystems widens in ways that do not reverse easily. Building a competitive robotics sector from scratch takes time that compound interest does not give back. And the factories that come online this year, running in complete darkness on the other side of the world, are already producing the goods that will be on shelves, in vehicles, and inside devices years from now. What China built is not just a factory that runs without humans. It is proof that the model scales, that the supply chain to build it is domestic, and that the capital to expand it is committed for the next 2 decades. That combination does not stay contained to one country for long. The companies that figure out how to match it or build something that makes it obsolete are the ones that control what gets made and where. If you want to see what the rest of the world is building next, this is the place to be.